It gives me immense pleasure to introduce our esteemed speaker for the 6th session, Dr. Shivashankar, who is working as an associate professor in the Department of Computer Science and Engineering at NIT Trichinopalli. He's a distinguished academician and researcher with profound expertise in cutting-edge fields like database management systems, artificial intelligence, machine learning, data analytics, and big data analytics. His academic journey is truly inspiring. He earned his PhD from Manoenmaniammai Sundarnar University, Tirunelveli, specializing in data mining. His thesis titled Design and Development of Efficient Feature Selection and Classification Techniques for Clinical Decision Support Systems underscores his commitment to addressing real-world challenges through innovative solutions. He holds an MTech degree in Computer Science and Information Technology from the same university, and BE UG graduation in Computer Science and Engineering from Madurai Kamaraj University, Madurai. He has spearheaded impactful research initiatives, which includes as a co-principal investigator of a project sponsored by NRB DRDO focused on artificial intelligence-based integrated logistics management system with a funding of 22.20 lakhs. As a principal investigator for well-funded project aimed at developing an advanced user interface with boiler steam leak signal intensity and frequency spectrum capabilities with a funding of 6.20 lakhs. His research contributions extended to supervising multiple PhD scholars, which includes both full-time and part-time scholars, covering diverse areas like recommended systems, customer churn prediction, fake news detection, text summarization, sentiment classification, and medical data analytics. He's a passionate educator who has taught a wide range of courses, which includes all the areas of interest which was mentioned earlier. He has authored 13 papers in SCI indexed international journals, 5 papers in Scopus indexed journals, and presented more than 29 papers in international and national conferences. Additionally, he has organized 7 faculty development programs and workshops under reputed agencies like AICT, TechCube, and ISTE. His extensive academic and research experience, combined with his dedication to nurturing innovation and knowledge, has made him a leader in the field of computer science and engineering. Please join me in welcoming Dr. Shivashankar for the 6th session of the Faculty Development Program on Responsible AI. Thank you, sir, and over to you.
Thank you, Professor Surya, Madam, for a nice introduction. So, responsible artificial intelligence is a new topic to me. I was given the topic to talk about bias as well as fairness in an AI model. So we were building and deploying AI models for a long time, but we were not aware of these responsible AI features. So I have prepared some materials for responsible AI. I will share a lot of use cases in bias and how the bias is overcome by some fairness algorithms they are used in responsible AI. Right. To start with, responsible AI is an approach of developing, assessing, and deploying AI system in a trustworthy and ethical way. So we are going to develop, we are going to assess, and we are going to deploy AI system in a trustworthy and ethical way. So it is a framework for building AI system according to 6 principles, right? So whenever responsible AI is a model is built in responsible AI, it should meet the following principles. One is fairness and inclusiveness. The other is reliability and safety, privacy and security, transparency and accountability. So these are the 6 pillars of responsible AI once you deploy it in a real-time system. So let us first explore the systems 6 principle, and we'll discuss about bias and fairness in responsible artificial intelligence. Right. So you all know that we should treat everyone fairly, and we should have some inclusiveness policy in any organization. Similarly, whenever you develop a model, machine learning model or a deep learning model, AI should provide fairness in its solutions. So for people with similar symptoms, it should give similar recommendation of medicines. Or people with similar financial circumstances, it should generate a similar credit score. And similarly, people with similar professional qualifications, it should recommend similar job, right? So this is fairness. So whenever you have a recommendation system, people with similar symptoms, it should recommend similar medicines, or with similar financial circumstances, it should generate same credit score, or it should recommend similar jobs for people with similar professional qualification. So by this way, you can ensure that the model is going to be fair and inclusive. The next pillar of responsible artificial intelligence is reliability and safety. So whenever you build a critical AI systems, you need to ensure that it is reliable. So you can rely on that particular intelligent system, and it is going to be consistent. So it is going to be consistent for different types of users. It should be able to safely respond to unanticipated conditions. So you may have different types of users or different types of use cases. So it should safely react to unanticipated conditions and resist harmful manipulation by an individual. And the next pillar of responsible artificial intelligence is transparency. So whenever you use an AI system, it should be transparent. So crucial part of transparency is interpretability. So it is critical that people understand how the decisions are made. So for example, you want to shortlist a set of candidates for a recruitment process, and the company uses AI system to determine the most qualified candidates. You should be able to visualize. So what is the shortlisting criteria, on what basis the candidates are shortlisted. So the interpretability is the key component of transparency. So transparency, it includes global explanations and local explanations. So global explanations means what features affect the overall behavior of a loan allocation model. So when someone is granted loan, there may be some global features like assets, family income, credit score, and so on. So you need to explore and give both the global explanations as well as local explanations why a particular loan applicant is accepted or rejected. So transparency, it improves the model's interpretability based on both global explanations and as well as local explanations. And the next pillar of responsible artificial intelligence is privacy and security. So we need to protect the privacy, and similarly, we need to secure the personal and business information in a particular system, right? So security can be ensured by encrypting the data. So you can use the various encryption algorithm to encrypt the data, that both in transit as well as in rest. You can scan for the different types of vulnerabilities. We can have some audit configuration policies. You can restrict the access to resources and operations by user, account, or group. So by this way, you can enforce privacy and security. And the next is going to be accountability. So whenever you deploy an AI system, someone should be held accountable. So it's not an like AI is an intelligent system, it can work on its own. However, AI system should not be the final authority on any decision that affects people's life. The humans should have some meaningful control over otherwise highly autonomous AI systems, right? So these are the 6 pillars of responsible AI, right? So fairness and inclusiveness means it should treat everyone fairly, and it should not affect similar type of people. And the second pillar was reliability and safety. So the third pillar was transparency, where the component was interpretability. So interpretability, the model's interpretability should be visible in a hiring system, and it should take care of both the global explanation as well as local explanation. And the next pillar was privacy and security, where we discussed about encrypting the data at motion as well as at rest. Similarly, scanning for the different types of vulnerabilities, applying audit configuration policies. And accountability, you need to ensure that the final authority is left to the humans. So humans have some meaningful control over the autonomous AI system, right? So we'll explore fairness in artificial intelligence. So AI is impacting our lives, day-to-day lives, by means of smartphones or some surveillance camera. So we are using AI and machine learning techniques for high quality education, better for supporting better quality healthcare, for smart grids to balance electricity and so on. And the shortcoming of AI is going to be there is a bias, right? So we'll study some use cases for bias. So there is a discrimination towards a population created unintentionally or unknowingly, while the deployment of AI can whenever you deploy an AI, there is a possibility of bias. Like, so people, humans, they have bias towards their race, religion. Similarly, AI also unknowingly or unintentionally, they have a bias element in it. So we have some real-time examples for bias. So we have a criminal justice system for risk assessment, which is used to deny or approve a bail. So let us look into the first use case. So in a real-time example, human biases always result in a model with racial disparity. So for example, in United States, among the population that have been sent to lockup have blacks in disproportionate number, right? So for the same level of crime, the crime score is going to be higher for a black person compared to that of a white person. So when machine learn from this data to risk assessment, it propagates the human bias in the models. As a result, the model is found to have some racial disparity. So for example, we have two types of defendants having the same criminal history, but the risk assessment is a high risk for a black woman, whereas it is going to be low risk for a white male, right? So both of them, they have a similar criminal history in US, but for based on the race, the AI system assigns a high risk score for this black woman, and it assigns a low risk score for this white man based on the criminal history. So this algorithm, this AI algorithm makes mistakes with both black and white at the same rate, but in different ways. So it is going to assign high risk score to black defendants that result in lot of false positive, right? So a black defendant is assigned a high risk score, whereas a white defendant is assigned a low risk score, which results in lot of false negative, right? So this risk assessment scores are used by the experts to decide a term of sentence. So to be fair and ethical, bias should be analyzed and mitigated for factors like race, skin, color, nationality. So for different types of people, you get a different crime score based on race, based on the color, based on the nationality, and so on. So this is an legal expert system where for the same type of crime history, two people are assigned two different crime risk score. So a black defendant is assigned a high risk score, whereas a white defendant is assigned a low risk score. And the human bias has been propagated to the AML model. So it results in false positive for black defendants, whereas it results in false negative for white defendants. So here the bias occurs due to the factors like color, race, nationality, and so on. And this bias has to be mitigated. So similarly, Amazon has a same-day delivery services in US, and this company appears racist while defining the same-day delivery areas, right? So in US also, like there is a part of Atlanta, right? The northern part of the Atlanta is going to be home to 96% of the white residents. They have the same day delivery. However, the southern Atlanta, where 90% of the residents are black, is excluded from the same day delivery, right? So whenever you order a product or a service through Amazon, in northern part of Atlanta, you get it delivered at the same day. Whereas if you are going to place the order from southern part of Atlanta, you will not be able to get the same day delivery from Amazon. So if you look into the race of the people residing in northern part of Atlanta, like it has more white residents. Whereas if you look into the race of people in southern part of Atlanta, like 90% of the residents are black and they are excluded from the same day delivery, right? So this is due to some historical bias against African Americans, which are created due to the National Housing Act of 1934, where African Americans are excluded from getting mortgages, and in turn they got cut from getting into affluent neighborhood, right? So North Atlanta is going to be an affluent neighborhood, and based on the National Housing Act 1934, this African Americans are denied to get higher mortgages, and in turn they stay in south part of Atlanta, and even now they are being discriminated in the same day delivery service by Amazon. So this is again an use case for bias by this e-commerce companies, right? So this there is some framework of harm also in artificial intelligence. So we have something called the quality of service harm. It occurs when a system that does not work for one person as it does for another, right? So it works for one person, but it does not work for another system, another person. We call it as quality of service harm. So it recognizes a few user faces while it does not recognize some user faces, or it recommends some items for a set of individuals, whereas it does not recommend some items for a set of individuals. We say that it is quality of service harm. Similar to that, we have distributive harm. So it occurs when the AI systems extend or withhold opportunities, resources, or information, right? So if someone is denied a job due to race, gender, or religion, we say that it is distributive harm. So this occurs in school admissions, in lending money to a person, or like recruitment and so on. So some users are denied opportunities, resources, or information. It is known as distributive harm. So we have some examples for this quality of service harm, right? So we have an deep learning model, ImageNet classification model, where the fox squirrel is classified as a sea lion with 99% accuracy. So this happens due to the angle problem of the animal, right? So the image is taken in a different angle. So 99% like 99% accuracy, like most of the fox squirrel images is classified as a sea lion. And similarly, dragonfly is classified as a manhole with 99% accuracy. So here this happens because the texture of the surface is similar to that of a manhole pattern, right? So this could be due to training data imbalance problem and so on. right? So the last use cases for bias is like advertisement for housing and jobs are predominantly listed to wide population of Facebook users, right? So even jobs as well as houses advertisements are listed to wide population. Similarly, some premium products like shaving products, movie selection, information such as where you went to college, where you live, pages you like on Facebook. So they can invariantly indicate your race, gender, and age. Right. So based on the sensitive features, it is going to recommend something, or based on the proxy features. So proxy features means it includes demographic features, right? Based on the gender, age, like you'll be able to recommend the Facebook. It recommends most of the jobs or most of the housing advertisements to the white population compared to the black population. So we'll explore the sources of bias, right? So the bias, the different sources of bias is like the bias is generated due to the algorithm. The bias may be generated because of user interaction, and the bias may be generated due to data, right? So in the case of bias generated due to the algorithm, there is something called popularity bias, right? So most popular items are recommended frequently to users, right? So whenever you go for some shopping online, like most popular items are recommended to the users, whereas any recommender system should recommend rarely brought items. It should be able to cross-sell those items to the users, right? So, but less popular items are rarely recommended by the algorithm. So this we call it as bias generated due to the algorithm. So a recommender system recommends most popular items to the users rather than recommending rarely brought items. Here the bias is generated due to the algorithm. We also have bias generated due to user interaction, right? So for example, a bank has built a model to predict the ability of an applicant to repay the loan or his credit worthiness. So here the features are going to be the applicant's financial history, employment history, and demographical information. By using this employment history, financial history, and demographic information, the loan makes decision on data of credit worthiness, right? So in this approach also, like whenever you use a ML model, there exists some bias because loan managers have denied unfairly loans to the minority groups in the past, right? So it is built, this machine learning model is built by some use cases where the where the bank managers, they have denied loans unfairly to minority groups in the past, and AI will take this input and it will consider this group general repayment ability to be lower, right? So this is how bias happens to the behavioral data. And the last bias is due to representation bias, right? So in the case of ImageNet data set, most of the images are from the western part of the country. So when a model is trained on this data, it predicts well on western country images, whereas for Asian and African country images, the prediction accuracy is going to be less. So we also call it as sample bias. Like if your model is trained on data where sample size for a population is not enough, then the model won't be able to predict outcome accurately for the specific type of population, right? So these are the use cases where bias is generated, right? So we have bias generated by the bias generated due to algorithm. We have some popular products are being recommended quite frequently, whereas rarely brought items are not recommended. So we call it as popularity bias. Whereas in the case of behavioral bias, based on the model that is being built by an existing data, a manager has not granted loan or he has denied a loan to the minority group of applicants in the past, the AI system has taken that as an input and it consider the repayment ability of the minority group to be lower. It is due to the bias due to the interaction, and bias can also be due to because of the representation. So an ImageNet model is trained using data from the Western country images rather than African or Asian country images. So it performs well for Western country images, whereas it does not perform well for Asian and African country images. Right. So since the model is trained on a data with a sample size of a specific population, it won't be able to predict outcome accurately for that particular specific population. So this is how the bias is generated due to the algorithm. Now we have something called how do you detect the fairness of the machine learning model, right? So we need to avoid bias and we need to check for fairness of an algorithm. So the model is biased if the prediction accuracy for a specific group of population is either very low or very high, right? So we have some models to check the prediction accuracy for a specific group of population is either very low or very high. Here, detecting bias for a single feature is easy, but if you look into a combination of features like race, sex, and income, we may have to compare hundreds of groups, right? So while evaluating bias and fairness, we can use some colored shapes. We can use colors and shapes to evaluate the features. You can keep shape constant and evaluate color, or you can keep color constant and evaluate the shape feature, right? So you have you are going to represent the information by means of shape and color, and by keeping one of it constant and varying the other feature, you'll be able to check for the bias. So for example, consider this example, right? So you have two different features. One is going to be the color and the other is going to be the shape, right? So if you look into the overall accuracy for blue, the accuracy is going to be 70%. But if you look into the accuracy for shape, the circle with blue, the accuracy is going to be high. Whereas the rectangles, blue rectangles, the accuracy is going to be very low. Similarly, if you look into the other feature, the circle, the accuracy is going to be very low, whereas the triangle, the accuracy is going to be very high. So it means that for a particular subgroup of people, it is predicting, it is favoring, and there is a bias in the model, right? So how will you make a system that is fair enough? In the case of a machine learning or a deep learning system, is that we are going to have a protected set of features, right? So we are going to protect some features like age, gender, race, religion, and national origin, and so on. So these are going to be the protected features, right? So whenever you make any decision in using an AI model, you are going to protect the gender, age, race, color, religion, national origin, and so on. And if you are going to have a protected variable, like for example, let us assume that age is a protected variable and it is a continuous variable. You perform a correlation, Pearson correlation analysis between the age and the probability score. If there is no linear trend between the two, the correlation between them should be close to zero, right? So if there is no correlation between the age attribute as well as the probability score, and if the correlation value is going to be zero, then we say that the model is not biased with respect to the variable, right? So similar type of example, if the model, if the particular variable is going to be discrete, right? So if the protected variable like age, gender, race, religion, it is going to be discrete. So it has some discrete values. Then you are going to plot the average score of the different score bands by different genders and check if the if there is any convergence, if the model has no bias. Right. So these are the ways by which you can check whether a model has a bias in it. Right. So if it is going to be if the particular protected variable is going to be continuous, then you are going to use Pearson correlation coefficient. You are going to find a correlation between the protected variable as well as the probability score. If there is no linear trend and if the correlation value is going to be 0, then we say that the model is not biased if the protected variable is going to be continuous. Whereas if the protected variable is going to be discrete, then we are going to plot the average score by different score band for different genders. And here we say that for both male and female genders, it converges. So here it means that the model does not have any bias, right? So by using this protected features correlation as well as you are going to check protected features average score for different score bands. You will be able to check whether the model has bias or it is unbiased, right? So most of you would have used a supervised learning model in your research work, right? So in the case of a supervised classification, you are going to build a model with a set of training tuples for which the class label is known. So once you build a model, once you build a model using a training data set given an unseen data, it should be able to predict the class label, right? So a classifier is said to be biased if its decision changes after it is being exposed to additional sensitive features in the input. So for example, probability of y cap is equal to 1, z is equal to 0. So here z is the sensitive feature, y is going to be the actual output and y cap is going to be the predicted output, right? So y is going to be the actual output and y cap is going to be the predicted output, and z is going to be the sensitive or protected feature. It may be age, it may be gender, it may be race, religion, and so on. So the class label should be same for a particular pattern irrespective of the protected feature. So here both for protected feature value is going to be 0 or 1. So for both a gender, male or female, or for a black or white, the class label should be same. So this is how we ensure that there is no bias in the case of an classifier model, right? So the actual output is going to be 1 and the predicted output is also going to be 1 irrespective of the protected feature. So here the protected feature may be age, gender, race, religion, and so on. So this is how we ensure bias and fairness in supervised classification, right? So if the classes are imbalanced, so you all know about class imbalances. So whenever you build a model, you'll be training with more number of positive instances than negative instances. Then there is some bias in the model, right? So since there is lack of diversity within features. So for example, while you build a face recognition model, you train it with equal number of faces and non-faces within the class feature space. However, you ignore some latent features like hair color of the individual can also cause imbalance, right? So perfectly balanced data set should have equal number of hair colors, right? So face recognition system will be focusing on only the number of equal number of faces and non-faces images. But there are some hidden features that we may have not taken into account in the case of face recognition system like hair color. So this may also cause imbalance, right? So perfectly balanced data set should have an equal number of hair colors, right? So we call gold standard data set is a highly imbalanced data set. So dark hair color is more common in a real world scenario, whereas blonde hair color images are often used in publicly available data sets. So we have to mitigate the bias not only for the protected features but also for the hidden features, right? So we need to identify potential bias, and we need to mitigate the bias. So we'll study two algorithms in today's class to mitigate bias and explore fairness in an AI model. So there are two principal ways to incur fairness in machine learning model. So one is going to be bias mitigation. So given a bias input model and a data set, you are going to remove the signal to improve the fairness, right? So we are going to remove the particular feature that causes bias. It may be age, color, race, and so on. So we are going to remove the signal to improve the bias in bias mitigation, whereas in inclusion, we are going to add a signal or desired features, and we are going to reweight the signal by which you will be able to remove the bias, or you can improve the fairness, right? So we'll study about two different architecture. So the first architecture we'll explore is like adversarial multitask learning to mitigate bias. So here our goal is to remove any effect of the sensitive attribute that has on the task prediction. So for example, you need to explore what is the effect of race on a credit risk assessment score, right? So given a particular input X, it is passed into a network via some embeddings and hidden layer, and output has two heads, one to predict the target variable and other to predict the sensitive attribute Z. So input is X, it is going to be passed to the network, and we are going to prepare embeddings, data embeddings for the input, and it is passed through the hidden layers. And at the output, you have two heads. One will predict the target value, and other will predict the sensitive attribute, right? So this is how an adversarial multitask learning to mitigate bias looks like. So you have the input data. You are going to generate some word embeddings. You are going to generate some vector like representation for the input X, and it is passed through some hidden layers. And usually you have a class label Y for an input. So in this adversarial multitask learning to mitigate bias, you have not only a class label but also have an sensitive attribute Z. So you have two discriminant output heads, one representing the class label Y and the other representing the sensitive attribute Z. So you are going to predict the sensitive attribute Z, and you are going to negate the gradient for Z head. So it means that we are going to negate the weight associated with that particular attribute Z, or we are going to remove the effect of this particular attribute on the decision. It is called as adversarial multitask learning to mitigate the bias. So I hope this architecture is quite simple to reduce the bias in your system. So you have some input X, you are going to generate some vector representation of the input. It is going to you are going to pass on the vector representation to the hidden layers, and you are going to generate the output. So output consists of two attentional heads, one representing the class label Y and other representing the sensitive attribute Z. So once you identify the sensitive attribute, what we do is that we are going to have negative gradient for the particular sensitive attribute. We are going to remove the effect of this sensitive attribute on this decision, right? So the idea behind a negative gradient or the particular attribute Z is that you are going to remove the effect of this sensitive attribute on task decision, right? So here the use case will apply the same use case. So we are going to generate a crime rate score for a particular individual. So it may be a white defendant or it may be a black defendant. For the same criminal history given as an input, it will generate the bad embeddings or vector representation. It will pass with this vector representation to this subsequent hidden layers, and output is going to be whether the crime score of a particular person or the penalty to be assigned to a particular for a particular crime. So here we are going to have some sensitive attribute. We are also going to predict the sensitive attribute, which is going to be a race of the particular individual. So it may be a white people or it may be a African Americans, black people. So once you identify the sensitive attribute, you are going to negate the gradient or weight values associated with the sensitive attribute. You are going to remove the effect of this sensitive attribute on this particular task decision. We call it as this model as an adversarial multitask learning to mitigate the bias. Right. So this is one of the popular architecture to mitigate bias in an ML model. Right. So we'll discuss more about this model. So this model simultaneously learn from a predictor and an adversary. So the input to the network is X. So here it may be a text or a census data. It produces a prediction Y. So the adversary tries to model a protected variable. So this protected variable may be a gender or a zip code. A gradient reversal layer is used to reverse the gradient of the adversarial loss during backpropagation, ensuring that the primary model lands representation that are invariant to the sensitive attributes. Right. So here the objective is to maximize the predictor ability to predict Y while minimizing the adversary effect ability to predict Z. Right. So you should be able to maximize the predictor ability to predict Y and minimize the adversary ability to predict Z. So this is how this model works. Right. So let us see an use case for this model. So for example, when you are going to use this adversarial multitask learning to mitigate bias. So initially, if you are going to train a model to complete analogy, so she is an analogy. Similarly, doctor, the analogy was using the conventional models. It was giving results like nurse, nanny, fiancé, maid, fiance, mother, dentist, woman, and so on. So once you remove the bias using this adversarial multitask learning, so it was able to give better analogy. So the better analogy was doctor to pediatrician, doctor to dentist, doctor to surgeon, and so on. So based on this adversarial multitask learning, we were able to mitigate bias and we were able to enforce fairness in a model. So this model looks quite simple. You have an input, you have a set of input to a particular neural network. So let us assume that X is going to be the input. You are going to generate some embeddings or convert it into a vector-like representation. You are going to propagate the inputs forward to the hidden layer, and then the hidden layer we are going to process the inputs, and further they are propagated to the output layer. In the output layer, you have two multi-head attention heads, one representing the class label and the other representing the sensitive attribute. So you are going to predict the class label as well as the sensitive attribute associated with the input sample. So here you are going to negate the gradient for the Z head. So negate the gradient means you are going to remove the effect of this sensitive attribute on this class label or on the task decision. So this model, adversarial model, objective is to maximize the predictor ability to predict Y while minimizing the adversary ability to predict Z. Right. So it can be used in it can be applied to large language models, and it produced better accuracy once you remove the bias component using this adversarial multitasking model, right? Here it has some limitations. One is that the user has to specify attributes that has to be debiased, and limitations is that there could be hidden unknown bias that are not necessarily known or apparent to the end user. By specifying the sensitive attributes, we will propagate our own bias in the model. So these are some of the limitation of this adversarial multitasking learning model. So similar to this model, to remove bias and enforce fairness, we have adaptive resampling model for automated debiasing. So here we are going to use a generative model to learn and uncover bias. So for example, consider a data set with many faces. We don't know about the exact distribution of a particular latent features, right? So we have discussed a use case, right? A face recognition system, you are going to train with equal number of face images and non-face images. So it will be able to, even then the accuracy, or there was some bias due to hair color, the face pose, skin tone, and so on. So even you train with equal number of positive instances and negative instances, equal number of face images and non-face images, there may be class imbalance due to variables such as posing of the face, skin tone, etc., which results in unwanted bias in the downstream task. So using generative model, we try to learn this latent variables to uncover underrepresented or overrepresented features, and we use them to mitigate those bias. So here we are going to use an variational autoencoder to learn the underlying latent structure, right? So for face recognition system, you are going to use an variational autoencoder. So here we are going to initially estimate the distribution of sensitive features. So it may be the pose, it may be the color, it may be the skin tone, and so on. So you are going to estimate the distribution of the sensitive features. We are going to adaptively resample the data. So either you need to undersample the data or oversample the data for a particular class. We are going to resample, and you are going to reweight the data during that training process, and you learn from a fair data distribution, right? So by using this autoencoder, we are going to do adaptive resampling for debiasing. So for example, consider this model. So initially in figure A, the model is disproportionately trained with samples. So it is trained with more white faces rather than black faces, right? So in figure B and C, we are going to resample and train based on some sensitive feature information. So we are going to undersample the white faces, and you are going to oversample the black faces. So in figure C, we are going to do some balancing activity. We are going to go for oversampling or undersampling. So for white faces, we are going to go for undersampling, and for black faces, we are going to go for oversampling. So then we go for reweighting the features, and finally you learn from the data distribution. You will be able to reduce the bias, and accuracy is improved. Right. So by using this variational autoencoder, so what we do is that we are going to use it for a face recognition system. We are going to resample the data. We are going to reweight the data, and we are going to learn from fair data distribution. So instead of a skewed data representation, we are going to learn from a fair data distribution. So this is how this works. So again, the fairness in AI may be due to procedural fairness. So the other is going to be distributive fairness. So procedural fairness, it focuses on decision making or classification process. So it ensures that the algorithm does not rely on unfair features, right? So you need to remove some unfair features in the feature set. And distributive fairness ensures that the distribution of both good and bad come is equitable, right? So the learning from fairness algorithm is that you can exclude sensitive features from the data set while you are building a model. So you can exclude the sensitive features like race, gender, age, etc. from the data set. So even you exclude the sensitive features by using other features like proxy features, name of the individual or a zip code, there will be some bias. So we can also exclude the proxy features because in some recruitment process, a name of a person is irrelevant. Right. So this is how we ensure fairness in a particular system. So we can use an variational autoencoder to resample. So you are going to initially choose a set of sensitive features. You are going to resample the data set with equal number of positive and negative instances. In this case, we are going to resample the data set with equal number of black and white people images, face images. You are going to reweight them and learn from the fair distribution of data. We call it as adaptive resampling for automated debiasing. Right. So by using this adversarial multitasking as well as this adaptive resampling, you'll be able to remove the bias and you can ensure fairness in your system. Right. So you can exclude sensitive features as well as proxy features. You'll be able to ensure fairness in the system. And last thing is that fairness from outcome can be computed using some probability measure, right? So we have D denoting demography, and G is going to be guess of the model. T is the true value. So irrespective of the demographic location, right? Demography equal to 0 or 1, the guess of the model is going to be the same. So the prediction for all subgroup must be fairly equal. So the model should be fair for all demographic values. So regardless of the demographic, the algorithm should predict the correct value. So independent of the demographic, the true value should be the same. So the model should be able to, the guess of the model or the true value should be same irrespective of the demographic. We have this measures like parity and calibration, right? So that's it about working with responsible artificial intelligence and how to mitigate bias using fairness algorithm. So we have discussed two different algorithms to mitigate the bias. One using an variational autoencoder and other we were using adversarial multitasking environment to reduce the bias. Right. So I think I have completed in almost 1 hour. Any questions from the audience?
Participants, the session is now open for queries. Kindly unmute yourself and ask the queries, or please put it in the chat window. So there is a question on the chat window. Could I read it to you, sir?
Madam.
Negate the sensitive attribute meaning that reducing the weight values while doing back propagation.
Yes, madam. So usually whenever we build a model, we have set of input. Input is X. It is converted into the input is represented in the form of a vector-like representation. The input is propagated forward. It is processed by the hidden layers, and you get an output Y. So here we are going to have two multi-attention head. One is going to be the class label. The other is going to be the sensitive attribute. Right. So for example, gender is a sensitive attribute or race is a sensitive attribute. So for example, for credit risk assessment, so it gives high like a high credit worthiness for a white individual compared to a black person. So what we are going to do is that we are going to have negative gradient for that particular sensitive attribute, so that the particular attribute does not have any weight on the final decision. So we negate the weight value associated with the variable which is going to be a sensitive attribute, which may be age, gender, religion, nationality, and so on. So that irrespective of the input, for similar type of input, it should give similar type of output.
I hope sir has answered your question, Meena.
Yes, ma'am. Yes, ma'am. I understood.
Thank you. The session is open for the queries. Kindly post your queries or unmute yourself.
So I was able to find only few algorithms in mitigating the bias. So we don't have materials available, and I have this adaptive resampling algorithm. Again, I think the concept is very simple. You are going to select a set of features. You are going to resample the data, reweight the data, and train the model, and you will be able to predict the class label in a better way. So these are the two common algorithms used to mitigate the bias.
Are there any metrics to evaluate all these parameters when we work with responsible AI?
Yes, madam. As I said that we have some two metrics. One is this parity and other is calibration. So here, like for example, let us assume that for different demographic, the output should be the same. The true value should be same. So D denotes the demographic, G denotes the model, and T denotes the true value. So for the so someone is from North Atlanta or someone is from South Atlanta, like Amazon should have similar, like you can verify that it is fair enough to have a same day delivery system. The output is same. You can identify using this parity as well as calibration. So once you use parity and calibration to check the model, we have some legal standard. So this algorithm, we are going to check for different demographics, what is going to be the true value. This value should be greater than 1 minus epsilon, where epsilon value is going to be equal to 0.2. So if this value is going to be greater than 1, we say that there is a level of fairness by the model. So that you can say that this model is not biased against a particular race or a religion and so on. So here they have taken demographic. So instead of that, it can be a race, religion. So I hope that the participants were able to follow. So for different, here the thing is that you are going to generate a score using a calibration gap. So for different demographic, when you apply the model, the truth value should be the same. So for the demographic 0, what is the truth value? And for the demographic 1, what is the truth value? You need to explore it. And if it is going to be greater than 1 minus epsilon, we say that it's unbiased. So this parity as well as calibration are the metrics used to check whether the model is fair and inclusive in nature.
Yes, sir. Thanks, sir. Session is open for queries. So participants, kindly unmute yourself to raise your queries or please post your queries in the chat window. There is another question in the chat window. May I use Shapley values calculation used as metrics in responsible AI?
Let me may use Shapley values. So you talk about explainable artificial intelligence, and you want to use it as a calculation. So for me, responsible AI is a new area. and I know that we can use Shapely for generating explainable AI code. So I'm not aware of this. Yes, this Shapely value is used in explainable AI. So like since these are emerging areas, like I'm not able to correlate both explainable AI and responsible AI as of now, but you will be able to find it out, madam.
Okay, sir. Thank you, sir. Thank you.
Dear participants, the session is open for queries. Kindly do unmute yourself to raise the queries, or please do post it in the chat window. So there is another question from
Yeah, yes,
the
madam. Can you
participant.
tell about the use of GradCam? Right, as I said that like I am working with AI models for a quite longer time, AI/ML models for a very long time. But this responsible artificial intelligence topics are like they are very new to me. I studied responsible AI bias and how to ensure fairness as part of this faculty development program. So few things are new to me, like I'm not familiar about this GradCam. Right. So thank you all for your active participation in this meeting. So I would like to express my sincere thanks to the team from PSG Tech, Dr. Sudha Sadasiva Madam, Dr. Surya, and other faculty members who are taken initiative and organizing this FDP program. Thank you all.
If there are no further queries, probably we'll conclude the session. And in case if you have any queries, please do send it to the mail ID of this FDP on responsible AI. We'll send it to Dr. Shivashankar sir and get back to you. So let us formally conclude the session. On behalf of PSG College of Technology, Coimbatore, and everyone present in the online, we extend our sincere gratitude to Dr. Shivashankar for his invaluable contribution to the 6th session of the FDP on responsible AI. So the insights that you shared has provided us with a clearer understanding of transformative potential responsibilities getting associated in the domain of responsible AI. So once again, I thank you for enriching us with the knowledge and the other perspectives related to fairness or the biased concepts of responsible AI. We look forward to the opportunity to learn from you again in future. So I would like to convey my sincere thanks to Shivashankar sir.
Thank you, madam. Thank you all for your participation.